Hello and welcome to my YouTube video on Toyota Evap systems. When trying to troubleshoot Toyota Evap systems, I have found it very difficult to get the proper information of how the system really works. And on top of that, I found that a lot of the sensors are called different names, making it even more confusing. The scan tool, the service manual, and the wire diagrams all use different terminology for their sensors. So I thought I would make a video and just explain some of this a little better so people that are having problems with the Toyota Evap, the PO440 and the PO442 and 446, that they would have a better chance of troubleshooting these. So first let's look at just a general overview of what the Evap system is. When you put the fuel into the fuel tank, the charcoal canister scrubs out all the hydrocarbons. They stick to the charcoal so that the fresh air can drain out. And then the computer will turn on this purge valve and it will suck these vapors back into the engine and just burn them just like it does the fuel. And what's not shown here is the air filter. Usually located somewhere around it is the vent valve, which allows fresh air in as it purges out these fuel vapors. Okay. So this is an overview of a typical Toyota system. They're not, every year they make some changes to this, so this isn't absolute to your system, but it's a good idea of what they're doing to monitor the evap system. So first, from the air filter, you're going to have the VSV for CCV. Now Toyota uses 3 solenoids to control its system, and then it monitors what's going on with the fuel tank pressure sensor, or sometimes they'll call it the vapor pressure sensor. So the VSV stands for variable switching valve, and it just means the solenoid. So the VSV for CCV is code for charcoal canister vent, or sometimes they'll just say the vent valve. And this allows the fresh air into the charcoal canister as it's going up and purging the vapors back into the intake. The VSV for evap can also be called the purge valve. And then the VSV for pressure switching valve, this is what Toyota uses to isolate the charcoal canister from the fuel tank and fuel cap, so that it can try to pinpoint where the problem exists. So this is how it's controlling. It's literally sealing the system through this valve. Anything on this side and anything on this side do not interconnect when that valve is closed. They're completely separated. Okay? So let's look at what happens when you put fuel in. As you're putting the volume of liquid gas into that, the air that's in the tank has to go somewhere. And as it vents out, it has to have the raw fuel vapors removed from it. So it goes through this piping system to the charcoal canister, and the charcoal absorbs the hydrocarbons or raw fuel, and what comes out is just the air. So it's a real nice design. There is a little safety right here that will open to allow this pressure out. It's a little diaphragm, and if the pressure gets close to 0.3 psi, this valve will open. So around 0.3, a little before, it's going to open this valve, because if you had too much pressure, then the air would try to come back up the fill tube where you're putting the gas in, and then your nozzle's always trying to click off. So that's where you're trying to put gas in and you put like 30 cents in and it clicks off, and that's very frustrating. Well, what's happening is your venting system is not allowing it to purge out. Something has malfunctioned with that. And so during the purge part of it, where it reclaims these fuel vapors every time you're driving the car, this vent valve, which is normally open, allows fresh air from the air filter. So it's on the filtered side of the air filter, and this fresh air comes in and mixes in with this charcoal and picks up these fuel vapors, and then it pulls it into the engine and burns it just like it does the fuel from your fuel injectors. So that's the basic concept of how they keep these fuel vapors from getting into the atmosphere and polluting. Now, as part of this system goes, there's a lot of safeties. You see these little valves here, and these safety valves. What they are is if the car rolls over, they will seal the system off so the gas doesn't try to just puddle out and cause an explosion or something like that. So they try to put as much safety as they can, and part of that is built into the fuel cap. So you'll notice anytime the check engine light comes on and you get an evap code, then most people, the first thing they tell you is change the fuel cap, and there's good reason why. The fuel cap is very complex and can have a malfunction. The first thing you'll notice is a vacuum spring, and if the system malfunctions, if this system, let's just say this gets an obstruction and then this accidentally sticks open, well, anything can happen. Well, the engineers put a safety on this. If something malfunctions and this fuel tank starts to take on vacuum to any amount, this little valve will pop off its seat and it will allow outside pressure into the tank, okay, to prevent the whole fuel tank from sucking in, from collapsing, so to speak. So that's what they're trying to prevent. Also, if something happens, let's say you pull over something hot and the fuel starts to boil in the system and there's a malfunction that doesn't allow the, and right here at this drain where it has this 0.3 psi to open this diaphragm, if this diaphragm messes up and it can't vent for whatever reason, can't vent that pressure off, then there's a safety in the cap to let it off. So the engineers are trying to keep the fuel, which is from exploding. And so with all this going on, and then here you have the seal, which of course just wears over time, it is a good idea when you service the evap system to change the cap out, because they are prone to malfunction and give problems, and then the check engine light's coming back on. This is what the charcoal canister looks like. There are many different designs. This is just one of them, just to give you an idea. This valve here, the pressure switching valve, and the fuel tank pressure sensor are located. There's the pressure switching valve right there. That's the solenoid, and then this valve right here is the fuel tank pressure sensor. And so when this system, typically if it has a leak, has a problem, then you need to pressure check it. And the way you do that, when that happens, you have to crimp this off right here at the yellow line, or you have to put something in this hose to seal the system. There's no way to pressure check this system, because less than 0.3 psi will cause that diaphragm to lift up and it will leak out, and you will wrongly condemn the charcoal canister as being the problem. Now, granted, on the Toyotas, when you have an evap problem, probably 9 out of 10 times it will be the charcoal canister. These little diaphragms dry up and they crack and they leak inside here, which you kind of seen that. These little diaphragms right here and right here are what you're looking at when you see these pods. And so those diaphragms will leak and it will fail the checks that the computer does on the system and have the check engine light on. So how do you find those? Well, you have to test the system the same way the computer tests the system. Now that leads us into the confusing part of what is inches of mercury. When you have, the first thing is that units of pressure, there is no such thing as negative pressure. Okay, even in outer space, there are minute amounts of pressure. There is no negative pressure, it just goes down to zero. These different units all go from high to low, except inches of mercury gauge pressure, or as many people like to say in automotive, inches of mercury vacuum. Okay, so atmospheric pressure at sea level is 14.7 psi, and on the gauge, so most gauges mechanics have, they'll have, from 1 to 15 psi, and then they'll have that 0 to negative 29.92, or wherever the scale stops at. So that part of it is called inches of mercury gauge pressure, and it's at sea level it starts at 0 psi and then it goes up. So that is very confusing when you're starting to deal with this. So just keep in mind, in automotive, when I talk about inches of mercury, I'm actually talking about the vacuum side of it, or taking away from sea level, which is 14.7 psi. When you test the system, you're going to have to activate those solenoids. So for this case, this solenoid, the vent solenoid, is normally open, and you're going to have to close it to seal the system. The purge valve is normally closed, and you're going to have to open it momentarily to pull a vacuum on the system. And this valve, if it passes, if when you run the checks, if this side of it passes, then you open this valve to check this side of it. And I'll explain that just a little bit further. The reason I typically do these manually is because I do have bidirectional control on the scan tool, but for me and my tool, I don't have the dealer scan tool. It will only activate the solenoids for about 10 seconds. So that's not enough time for me to really, I like to have full control over it. So I just manually activate them. And if you're going to do that, you can use a T-pin to jumper in just like this, and you take a test light. And on most of the Toyotas, you need to look at a wiring diagram, but most of the Toyotas, they use ground, so they have power running to them at all times, and the computer just grounds it. A word of caution: if you're doing it this way, you better be sure what you're doing, because you can fry the computer, because the other side of this wire, what it's connected to is the computer, and it's a very expensive mistake if you let the smoke out of it. What's easier and more safer, but because I do this professionally, I do it this way because it's easier for me. But if you're in doubt and uncomfortable with that, just use a jumper wire. So just unplug it. So you take the computer out of the loop, and one side you add power to through a fuse jumper wire, and then the other side you just ground. And so the preferred type of jumper wire has these little sheaths over them that protect them. Try to avoid using these, or you're going to see some sparks. Okay, so let's look at a bad charcoal canister waveform. What I'm using here, I'm having the picoscope, and I'm using the WPS 500, which is a pressure transducer, and this is set for inches of water. Okay, so that's what this system has to be tested at. And to get an idea of what inches of water is, 14.7 psi is what sea level pressure is, and that equals 29.92 inches of mercury. Okay, so 1 inch of mercury is basically a half psi, or you could say 1 psi is 2 inches of mercury. And we're dealing with vacuum here when we use this type of scaling. 1 psi equals 27.68 inches of water, or H2O. We just call that 28. So we're not using scientific measurements here. We don't need that level of accuracy. Inches of water is close enough. So you might say 28 inches of water is 1 psi, or you can say 1 inch of mercury vacuum is 14 inches of water. So you kind of see the scale here. If you look at this scale, 140 inches of water in psi, it'd be 5 plus or minus 5 psi. So this direction is 5 psi, this direction is taking away 5 psi. Keep in mind, when you're adding a vacuum to this system, you don't want to overdo it. You don't want to just hold down the purge valve and let it just suck continuously. This time scale that I'm holding this down is not very long. So I'm monitoring this as I'm doing it because I don't want to damage the system. It's kind of like a soda can. If you pull a vacuum on it, it's just going to crunch in. You don't want to do that to the evap canister, the charcoal canister, or the fuel tank. So you have to be careful with that, not damaging it. So what I'm doing here is I have the canister vent valve. I have it closed. And so when I activate the purge valve, I have the engine running. I should pull down into a vacuum, and it should hold the vacuum. This car had had 3 codes: the P40, P442, and the P446. And so when I've got the vent valve closed. So when I activate the purge valve, the vacuum starts to happen, and then the minute I let off of the purge valve, it just immediately rises up to atmospheric pressure. So this system is definitely not holding vacuum. Now let's take a look at this diagram again. I'm only checking this part right here. This is all I'm testing. This part over here, because I haven't opened up this pressure switching valve or bypass valve, it's normally closed, and it stays blocking off this until the computer opens it. So I'm not checking the fuel cap, I'm not checking the fuel tank, I'm not checking any of the piping on this side of this valve. I'm only checking the charcoal canister, the purge, and the vent valve, and the piping that goes back to the engine. So I automatically know that this system either has a hole in the tubing, or it's got a bad charcoal canister. So even though there could be other problems with this system, I'm going to have to put a charcoal canister on it before I can check the rest of the system. This system can only be checked with a vacuum. Okay, if the charcoal canister passes this vacuum test, but then when you open it up to the fuel tank by activating this bypass valve, and you open this and now you pull a vacuum and it doesn't hold vacuum on the fuel tank side, that's when you have to use pressure. And remember, you have to plug this off to use pressure to see where it's leaking from. So you've already did the integrity check on the charcoal canister and it passed. Then you've got a fuel tank problem, a cap problem, something like that. And for that, you can use pressure. So that's how this system was designed. That's what the computer uses to check it out. So the first thing we have to do on this one is replace the charcoal canister. Now we put a new charcoal canister on it, and we're going to run the same check again. So we have the vent valve closed. We've manually grounded it so it's closed. And then the purge valve, we activate it right here, and it pulls down, and then we let off, and we watch it, and it holds that vacuum perfectly. So there's absolutely no change in that. And then I add a little more vacuum, being cautious. I'm not trying to collapse the fuel tank or anything. I pull down and I let off, and it holds that vacuum perfectly. So I'm very comfortable that this brand new charcoal canister from Toyota is working just like it's supposed to. Now let's check the rest of the system. So at this point here, I open the bypass valve. So all of this has checked out good. Now I'm going to check the rest of the system, because I want to make sure when he leaves here and that evap monitor runs, I don't get that check engine light back on. As I'm doing this, I'm also using the scan tool to watch this fuel tank pressure sensor. And I'm watching those values. Even though the computer is designed to understand the values, it's just giving me a voltage reading, and I'm just watching for movement. I'm not really trying to see if it's an exact match or not. The sensor's brand new, but as I do this, as I run these checks, I make sure that this is responding to what I'm doing. And I'm also watching the laptop screen to make sure. So now I'm going to open this valve. So I manually do that right here, and this opens up the fuel tank, which has pressure on it. So I'm in a slight vacuum, you might say, and then the fuel tank pressure equalizes, and then I add a little more. So I'm hitting the purge valve right here. I'm cycling it. The purge valve is pulse width modulated, which means the computer cycles it off and on. So you don't just hold down on the purge valve endlessly. The windings weren't in the motor in the solenoid weren't designed for that, and if you just hold a ground to it, for one, you're going to hurt the system, because the engine's going to suck a vacuum on it, but you're going to overheat those windings and possibly damage that purge solenoid. So I'm cycling it off and on, and then I let off on it, letting it seal, and the pressure starts to increase. Now remember, we talked about the fuel cap having this little vacuum release spring. Well, that's what's happening in this part of it right here. So that cap is releasing that vacuum, and then it reaches its equilibrium, its state where it's no longer allowing pressure in, and it equalizes right here. So that's real nice. So if you look at the bad one, the minute I let off, it went straight to atmospheric pressure, or what we'll call gauge pressure of 0 psi. The new one, it actually stayed at 22 inches of water below the atmospheric pressure, which for me is 14.7 psi. So we're holding 22 inches of water less than atmospheric pressure, which is the design of the system. That's the fuel cap is going to release that vacuum. It's part of the safety of it. Right here, now keep in mind this is 0, so this is what the atmospheric pressure is, and this is where I'm at right here. Now I release the vent valve. So I take and momentarily open this up by taking the ground off of it, and a pressure immediately rises. So now I'm comfortable that my vent valve is working properly. I put the ground back onto it and seal it off again, and the vacuum that's still in the fuel tank, because it's a big system, it immediately pulls it down. Now that didn't happen because of the purge valve. That happened just because there was lower pressure in the fuel tank than there was in atmosphere, and the minute I closed that leak off from the vent valve, it pulled it back down and equalized again. So now with this, I'm confident that the system is working good, and I'm very hopeful that the computer, when it runs all of its checks, will not turn the check engine light on. And so usually these monitors take a few days to run. This particular car had a full fuel tank, so it was impossible to run it until its fuel level dropped a little bit. So that was it. And just a little bit down, a few weeks later, we touched back with him, the customer, and the check engine light never came back on. And so we suspected that this would have it all fixed up. And so I hope this is helpful for you when you go to troubleshoot these Toyota Evap systems.